course from Hayes-Harris textbook. Table alongside shows grades received by university students taking a second-year computing science course. Okay, so high distinction, credit, pass, fail. I think like in the UK that's a first, 2-1, 2-2, third, a pass, fail. Okay, something like that. So following assessment, a new coordinator is appointed for the course. The new coordinator is concerned by the high number of high distinctions and distinctions awarded. Well, they could just be working really hard. And once determined if the course should be adjusted. Could just, anyway, it is considered usually 5% of students receive a high distinction, 10% blah, 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 blah. Conducts a chi-square goodness fit test to determine whether the course should be adjusted with a 5% level of significance. Okay, so the first thing we should do if we're asked to carry out a chi-squared test is write a null hypothesis. The null hypothesis is that high distinction, passing a high distinction is 5%. 0.05, passing to the proportion of students that get a distinction. So we could say, or 2, P2 is 10%, which is 0.1, possibility 3 is 0.15. The probability of getting a credit is 0.4, 40%, and a fail is 5 people. Okay, sorry, 30%, 0.5 is 0.3. So we're stating that the H0 is that it fits the distribution that's being suggested. Okay, H1 is therefore that P1 does not equal 0.05, that P2 does not equal 0.1, that P3 does not equal 0.15, that P4 does not equal 0.4, and P5 does not equal 0.3. Right? So it's simply, yes, it does fit, or no, it doesn't fit, okay, a goodness of fit. So we're stating that the level of significance is 5%, 5% significance level, that's in the question, it's here, significance level, sorry for my writing, and then we're into the rest of it. So the first thing we need to do is we need to create a expected frequency table. I'm not going to do all of it on here because most of this is calculator work, but what I do need, so let's go for grade, let's call it high distinction, credit, pass, fail, okay? So we've got the frequency, the observed frequency is here, remember this is observed, and here we're going to calculate the expected frequency. To calculate the expected frequency, we need the total number of people. We're going to times that by the probability of that happening. So in this case, it's going to be total times by 0.5. It's going to, distinction is going to be total times 0.1 all the way down. We've got access to a GDC, so I'm not going to do this by hand, but in an exam you could easily be asked what is the expectation. Because it's a goodness of fit, we're going to be enlisting spreadsheets, and we need to input our observed frequencies. So we're going to go for a high distinction, a 16, a 21, a 21, a 59, and a 34. I'm going to be lazy. It's a spreadsheet. I'm going to say, right, equals 151 times by 0.05. There you go, 7.55. So that's the expected frequency, okay? So the expected frequency for this one is going to be equals the total number of people times by the likelihood of it happening according to the distribution. We equals 151 times by the probability 0.15. We're going to do equals 151 times by 0.4. So the thing that we need to get used to is that conversion between percentage and decimals, okay? Equals 151. Because you'd be typing this into a calculator anyway, why not use a calculator to do it for you, 0.3. So we've inputted our observed frequency in the first column. We calculated our expected frequencies in the second column. Now we're going to carry out a goodness of fit test with the use of the GDC. So menu, statistics, stat test, chi-squared goodness of fit test. Where do we put our observed data? Well, we put it in the A column. Where do we put expected? B column. Where do we want our answer? Well, we don't want to overwrite our data, so let's put it in C column. And again, I've forgotten to put the degrees of freedom. Degrees of freedom for this is we have high distinction 1, distinction 2, credit 3, pass 4, fail 5, 5 take 1 is 4. Hit enter, and we get these values. We get a chi-squared critical, chi-squared calc of 14.7, and we get a p-value, calculated p-val of 0.0052, let's just check, this level, 529, okay, according to 3 significant figures. Right. We haven't got a critical value in the question, okay? We don't have a chi-squared critical value, so even though we've calculated it, we cannot use the calculated value. We're going to have to make a judgment purely off the p-val. Okay, so here we're going to need, I'm just going to use this space. We're going to need a sketch of our distribution. Okay, we're approximating. Here we're going to have chi-squared, and we're going to put in our significance level. Okay, so here is the line that's critical. Significance level, we need 0.05. If we manage to get to the left, we're in accept territory. Okay, to the right, we're in reject. So now we need the pink area, 0.005. So the pink area is going to be something like this. Sorry, I should move the green arrow to the total green area. The pink arrow, we're now firmly in the reject. Okay, so we can definitely say, as a judgment, reject H0. Why can we reject? Because 0.00529 is less than 0.05. P-value calculated is less than significance level. What does that mean? Well, it means that the person's just being a bit harsh. The new coordinator is a bit sad. People could have been working really hard, and I don't think anybody should be tested according to a scale like that. You should get the credit for what you've done. Yeah, looking at that, like theory of knowledge, if he says 5% of students receive a high distinction, what if the entire cohort get 100%? Hey, never mind. Okay, so I'll pause this call. All right, any questions around?